All right, so now we're going to look at radiation reactions, okay? Rad reactions. These are actually kind of half reactions, but what we can do is we can have there's sort of two different types, so I'm going to split this in half, and then I'm going to kind of move over on this side. The first kind of reaction you can have is a decay. So, for example, if I told you that uranium 235 undergoes alpha decay. What that means, is that uranium-235 emits an alpha particle. It's going to create an alpha particle. And when it does that, it's going to make a new nuclide. It's going to make a new isotope. It's going to possibly even a new element, okay? So when we talk about decay, we're going to do a reaction. And so the first thing we need in the reaction is we need uranium-235. So to remind ourselves, right, uranium-235, the 235 goes in the upper left-hand corner. That is the atomic mass of this uranium isotope. Good reminder. We need the atomic number of uranium, and that is 92. And I get that from the periodic table. I'm not going to pull up the periodic table. You can reference your own periodic table for that. So alpha decay means that what it's going to do is it's going to spit out an alpha particle. It's going to eject an alpha particle from itself. So when I do this, I like to write the particle it makes first. And the particle it makes is alpha. And so we go back to that chart, and we realize alpha particle is just a helium nucleus. So it's He42, right? So it will then also make something else. So this is the fun part of this, right? So remember back when we did balancing equations, right? Everything on the left-hand side had to add up to give you everything on the right-hand side. And that's going to be true on these equations as well, except now it's going to be the masses and the numbers that add up. So we're going to look here, and we're going to see we have 235 on the top over on the left-hand side, so we need two numbers that add up to 235 on the right-hand side. We already knew the alpha decay part, right, because it said alpha decay, so that's where that comes from. That's the alpha particle. So what is going to be the other thing that's created here? Well, 4 plus what number will give me 235? So 4 plus 231 equals 235, right? So I'm going to take that 231 and I'm going to put it in right here. On the bottom part, we got 92 on the left and we got 2 on the right. So 2 plus what number will give me 92? Well, that would be 90. So we're going to put 90 down here on the bottom. Now that I've got 90, what I need to do is I need to look up what element is element number 90. So element number 90, if you look, down here is element thorium. It's got a TH for its symbol. Now notice it says 232, and that is not where we're getting for the mass, but that doesn't matter. The mass can be a lot of different things based off of what isotope you've got. So thorium is what we're going to put as the symbol here. And that's how you do this sort of thing. All right, so I'm going to give you another problem. I want you to give it a try and see if you can figure out what it is. All right, and the one I'm going to give you, I like this one, is carbon... Carbon-15 undergoes beta decay. So I want you to try and write down what you think that one's going to look like. Pause the video, and I'm going to show you what the answer is. All right, carbon-15 means we put a 15 up here. Carbon is element number 6, so it gets a 6 on the bottom. Decay, and it is beta decay. So remember, beta decay is an electron with a 0 for mass, a 0 for mass, and -1 for the atomic number. All right, so what do we got to have? Over on the left-hand side, the top's got to add up to give us the right-hand side, or the right-hand side going to add up to give us the left-hand side. So we're going to have 15 up top because 0 plus 15 gives me 15. And then on the bottom, we need 7 because 7 plus -1 gives me a 6. So what element is element number 7? Well, that would be nitrogen. So it creates nitrogen 15 when it undergoes beta decay. Kind of cool. All right. What about the other kind? The other kind is called capture. It is where we're going to do the exact opposite of decay. So, for example, we could have, let's get a good element for this. Let's do Argon 40 undergoes alpha capture. All right, so on these kinds of reactions, if decay, if the particle was on the right-hand side, in capture, the particle is on the left-hand side. So we're going to have Argon 40, Argon with a mass of 40, and Argon has a number of 18. That's atomic number of 18. It's going to undergo alpha capture, so alpha is 4,2He. So now it's even easier. We see the plus on the left-hand side. All we got to do is add them up. So up top, we're going to have 44. On the bottom, we're going to have 20. What element is element number 20? Well, that is calcium. And I can show you that on the periodic table real quick. There's, underneath my face there's calcium right there, element number 20. Clicking on that should mean calcium, element number 20. And so that's why we put calcium in here, because it's element number 20. We go based off of the 20. All right, so there's one other one that I want to talk about really quickly, and it's one of my favorites. Barium is one of my favorite elements. It's super poisonous and super dangerous. Barium 138 undergoes gamma capture. All right, so barium 138 looks like this, Ba with a 138. If we jump back over the periodic table real quick, we see that barium is element number 56. So its atomic number is going to be 56. That goes down here on the bottom. We are going to add to that gamma capture. So gamma, it's that funny upside-down fish standing on its head sort of thing. 0, 0. And by the way, I put too many fins on that fish. There we go. That's what gamma is supposed to look like right there. Some people draw it a lot smaller. I'm not one of those people. So here's the thing about gamma capture, right? You notice what happens to both of those. They don't change, right? So over on the right-hand side, the top number is going to be 138. Doggone it, 138. And the bottom number is going to be 56. There's no change there, right? So this is still going to be barium. What we like to do with gamma capture is to show that a particle is actually being taken on, is we'll put an asterisk on this thing right here. It means it took on a little bit more energy. And so if you ever see gamma capture or gamma decay, right, if I started off with, like sodium 23, element number 11, and it had an asterisk, you know the thing that it's going to lose is going to be a gamma particle. Because this is an asterisk, that's what it means. It's just got a little bit excess energy as a part of it, which is kind of neat. So anyways, that's how you balance a half reaction. And now you have the ability to do this for your homework.